All right, I've been asked to make a video on graphing rational functions. So this is number 15 from the cumulative review. And you can see it's a function written in standard form. I have a quadratic on top and on bottom. First thing I'm going to need to do is get the factored form of that because I need it for the wholes and the vertical asymptote and the x-intercept. So that means that, there we go. I need to factor both the top and the bottom. So on top, I have x squared plus 6x plus 8. I need paired numbers that multiply to give me 8, add to give me 6. That's 4 and 2. So on top, I get x plus 4, x plus 2. On bottom, I have x squared plus 2x minus 8. So I need numbers that multiply to give me negative 8 and add to give me 2. So that's going to give me x plus 4, x minus 2 on the bottom. All right, so how does that help me with the wholes? I take this factored form and I can cross off the x plus 4 because that cancels out. It's on both the top and the bottom. The thing that gets canceled out, that factor or factors, is what give you the wholes. So you take that factor, set it equal to 0, and solve. That gives me x equals negative 4. And then you plug that back in to get the y value. You take the simplified form of this function after crossing this off, which just leaves the x plus 2, x minus 2. So if I plug in x equals negative 4 to that, I get, that comes out to negative 2 over negative 6, which is positive 1/3. So I have a whole at negative 4 in x, 1/3 in y, and it's going to look like that on the graph. All right. I can also get the vertical asymptote from the factored form. So the vertical asymptotes are from whatever factor or factors are left on the bottom after you cancel. So they're things that are only on the bottom, not the top. In this case, we have an x minus 2. Set that equals 0, we get x equals 2. So we have a vertical asymptote at x equals 2. That's what it looks like on the graph. And if you put it together with the whole that we already knew about, that's what we have so far. We have a vertical asymptote and a whole. These two things together give us our domain restrictions. X cannot equal negative 4 or 2. And since the domain goes from negative infinity to infinity, that gives us one section of domain from negative infinity to negative 4, one set of domain from negative 4 over to 2, and then finally one from 2 over to infinity. So we just write, for the domain, we write each of those sections in parentheses and then put this union sign that looks like a capital U in between them. All right, so we can also get the x-intercept from the factored form. So the whole is the thing that's on both top and bottom. The vertical asymptote is on the bottom only. The x-intercept is whatever's left on top, because for an x-intercept, y equals 0. Well, this function, y equals 0 if the top of the fraction equals 0. So we take this factor from the top, set it equal to 0, and solve. If you have more than one factor left up top, you would have more than one x-intercept. But each one of them, you get an x value, and then y is 0. So we have an x-intercept at negative 2, 0. Now I can put that on my graph as well. It's right there. So all of this is from the factored form I have up here in red. As you can see, the graph is not complete yet. There's more information that we're going to be able to get from the standard form. All right, so going back to the standard form, to figure out the y-intercept where it crosses the y-axis, that's where x equals 0. So we take our original standard form function and we just plug in x equals 0. So 0 squared plus 6 times 0 plus 8. 0 squared plus 2 times 0 minus 8. Everything cancels out because 0 times anything or 0 squared, that's all 0, it doesn't matter. So we get we get 8 over negative 8, which comes out to negative 1. So we have a y-intercept at x equals 0, y equals negative 1. And we can put that on the graph. Finally, we've got horizontal or slant asymptotes and in behavior, and those all kind of go together. You want to look at the highest exponent on top, that's this right here, the 2. And you want to look at the highest exponent on bottom, that's this 2 right there. We've got 3 cases. Either the exponent on top is smaller than the one on bottom, in which case we have a horizontal asymptote on the x-axis at y equals 0, no slant asymptote, and the in behavior for negative infinity and infinity in x, y goes to 0, matching the horizontal asymptote. Or, second case is they're the same. If those two exponents are the same, then you have to divide the first two terms. So we're going to do this in just a second. And we're going to get y equals a number for the horizontal asymptote. We'll still have none for the slant asymptote. And now for our in behavior, instead of y going to 0, it will go to whatever that number was for the horizontal asymptote. In the third case, the hardest case, which you're not going to see very often, is if the exponent on top, the highest exponent on top is greater than the one on bottom, then you won't have a horizontal asymptote. You'll have to use synthetic division to find the slant asymptote, and it'll be a linear function. It'll be in the form y equals mx plus b. And then you'd have to graph that line, that slant asymptote, and you'd have to see on the left as x goes to infinity, is y going to infinity or negative infinity? Does it start off low or high? And on the right hand side as x goes to infinity, does it go to infinity or negative infinity? This will always be either infinity or negative infinity. But let's look back at our function. So our highest exponent on top is 2. Our highest exponent on bottom is 2. Those are the same number, n equals d. So that's our second case. So we divide the first terms. So we have x squared over x squared. And that just gives us 1 because everything cancels out. So we have a horizontal asymptote at y equals 1. We have no slant asymptote. And the in behavior as x goes to negative infinity or as x goes to infinity, y goes to 1, the value of the horizontal asymptote. So let's look at that on the graph. We've got that right here at y equals 1. Okay, we now have all the pieces. We can start to put it together. So we had all of this from the factored form, and now we've got this information from the standard form. It's still not complete. We need to fill in the gaps here. So finally, we can, on the left side of the vertical asymptote, we can just connect the dots. We can't cross the horizontal asymptote or the vertical asymptote, and so we get a curve like this. But we don't know what's going on over here. That's a big old question mark because we don't have any information on this side of the vertical asymptote in this case. Sometimes you might have a point over here already, but we don't. All right, so we need to know at least one point over here. So I just chose x equals 4. You could choose literally any x value over here. I just chose 4. And I'm going to plug that back into my simplified version of the factored form, which remember was x plus 2 over x minus 2. So I'm plugging in 4 for x. So 4 plus 2 over 4 minus 2. That's 6 over 2 is 3. So I have a point 4, 3, and I can go ahead and put that on. Once I've got at least one point over there, I can just draw my curve. And that's it. That's all I have to do. Let me know on the remind if you need more help.